Welcome to my projectbazaar.com.
We will discuss about the product for VLSI architecture design of guided filter for 30 frames per second full HD video. Next we will see the abstract for the product. Filtering is an image processing technique widely adapted in computer vision and computer graphics, computational photography, etc. More specially, filtering can be applied in many applications such as noise reduction, texture editing, detail smoothing and enhancement, colorization, tone mapping, haze, rain removal and joint upsampling. The most popular technique is the edge preserving bilateral filter applied to the bilateral filtering to the image noise reduction technique. Filtering is widely used to an image and video processing for various applications. Recently, the guided filter has been proposed and because one of the popular filtering method. In this paper, to achieving the computational demand of guiding filter in full HD video, a double integral image architecture for the guided filter ASIC design is proposed. In addition, reformation of the guided filter formula is proposed, which can prevent the error resultant from transaction in fractional part and modify the regularization parameter for the user demand. The hardware architecture of the guided image filter is then proposed and can be embedded in mobile devices achieve the real-time HD application. To the best of our knowledge, this paper also is known as the first ASIC design for the guided image filter with the TSMC 90 nanometer cell library functions. Next we will see the flow diagram for the product. The original images to apply to the processor and to add the noise for the pre-processing step, then add the noise for salt and pepper noise in this certain ratio, then noisy image to apply to the MATLAB process, then acquiring the binary points for the noisy image, then the noisy image to apply the double-six filtering architectures. The double-six filtering architecture obtain the random points for the noisy image, then apply to the DWT transformation. This DWT transformation to passing the Xilinx software. Then the pre-processing to apply to processed by the MATLAB process. Then the MATLAB results is stored by the one of the test architecture. The text results to apply the input for the Xilinx software. Then the Xilinx software to get the text and write the text integer values. Then apply the TWT transformation process. Then the DWT transformation process, one of the encoding work. The encoding work obtain the random points and to apply the DWT transformation. The transformation is mainly considered for the three processing work. First of all the reconstruction, then the decomposition and transformation thresholding region, then to reconstruct the original input image. Then three processes to be applied by the one by one ordering technique and to develop the Xilinx software. Then they apply the inverse DWT transformation to reconstruct the original input image and decode the random point section. The random point section to write the data for again to apply the text for the MATLAB process. The MATLAB process to resize the image and to reconstruct and to display the original noise removal image and to apply the MSE and BSNR value. The MSE value is mean square error and the BSNR means peak signal to noise ratio. How to remove the images, how to remove the noise from the original image to reconstructed image. Then we calculate the final results. And finally we see the output for the product. Just we select the main file and just open the main function, then create the main function, the pre-processing step to apply the MATLAB function, and the another steps transformation steps to apply the Xilinx architecture. We just open the function, then run the file. We select the any one of the images, just we apply the noise input for the process. The noise result is to be applied, and to go to the Xilinx filtering architecture block in ISC project list, then create the Xilinx project. Thus the nice input images to be applied by the Xilinx ISC project list. Thus the text document to apply the input for the Xilinx ISC project. Then open the Xilinx ISC results for our process. This is the input images for our the architecture. Then open the Xilinx ISC project navigator. Then apply the text input to the Xilinx ISC project navigator. Then select the filtering signal and to select simulate. Then calculate the simulate behavioral model functions. Then run the behavioral model functions and to run the simulation process. This process to activate the filtering work for the our text to result. Then the text result to write the any of the text and to apply the MATLAB functions. Then create the ISM project navigator. Just we activate the input signal processing for our architectures. Just to deactivate the reset and activate the enabling function. Just we activate the process only. Then close the our process. Then close the results and to close the all images. Then to press any key to display the output, which select the command window. Just we enter the process and retrieve the original output for our the process. Then calculate the BSNR and MSE value for the our project functions.